Flack math! Give me some math and I'll give you some flack. Flack math!
All right, today we are going to talk about the properties of isosceles and equilateral triangles. So what the heck are those?
The ones that are equal angles, right? Or like an equilateral and triangle can be like all angles are the same, right?
All the angles are the same and
all lengths?
All lengths of the sides. And that's literally what an equilateral means, because equilateral is equal sides. An equilateral triangle is also considered an equiangular triangle. So that's equal angular, equal angles, okay? So that's why they're, but it's really just with equilateral and equiangular. If it's an equilateral, it's an equiangular. And if it's an equiangular, it's an equilateral. Only with triangles though, because what about quadrilaterals? What's an equilateral quadrilateral?
Oh, just a square.
That's one example.
And
This
those
question
ones
was
where
on
it's
your
like
test.
angled.
Yeah, rhombus.
Yeah.
So that's not necessarily this was one of the I'm not going to tell you. I shouldn't tell you.
Oh
no, go ahead, tell us.
It wouldn't hurt.
It's one of the questions on your test, so be careful with that. It's
No.
only the case with triangles. All right, listen. In an isosceles triangle, the size of the angles. So what's an isosceles triangle then? What's an isosceles triangle then?
One angle is different, but the other two are the same, right?
Yep. And you're in like angle mode now. But
length
literally, technically, the definition of an isosceles triangle is the two lengths are the same and one is not. Okay.
But the lengths are the same, the angles are the same.
Yes, that's actually a property of an isosceles triangle, but technically the definition of an isosceles triangle is a triangle that have two or more equal sides.
But
Okay?
if we wrote angles, would you count us wrong on
Yep.
the test?
If you're writing the definition.
That's horrible. Okay.
Okay, so let's clarify here. So the leg of an isosceles. So if I wrote an isosceles triangle, drew an isosceles triangle, we'll call it ABC.
Mr. Flack,
Yes,
did you start the Zoom?
I did.
You.
Oh, look at that. Admit. I'm admitting him. All right, so triangle ABC. The leg of an isosceles triangle is one of the two congruent sides. So you know how like in a right triangle, the legs are the legs of that right angle. In an isosceles triangle, the legs are these guys. The two congruent sides. The two congruent sides are called the legs. Okay? So far, so good? Can you remember that? Because usually legs, I mean, there's two legs. I mean, that makes sense. We have two legs. So the two that go together are the two congruent sides. Okay. So in this case, it would be the legs are AB and AC. Okay. And when you're naming a side of a triangle or a shape, make sure you say this line segment. Okay. You don't want to say the distance between A and B. You want to say the line segment AB and the line segment AC. Okay. The vertex of an isosceles triangle. Vertex is the point where the two congruent sides meet. Okay. So this is the angle. The vertex angle is angle A, right? Vertex angle. Which kind of makes sense because there's only one vertex and it's not going to be one of those other two angles. So that's the vertex angle. And then you have the base of an isosceles triangle, which if it's drawn like this, it's easy to see because it's on the bottom. But it doesn't have to be drawn like this. If you had a isosceles triangle that looked like this, this would be the base, right? It's the side that doesn't belong. It's the odd man out. So the base side, base is BC in this case. So far, so good? Okay, and then just one more definition. Base angle. There's two base angles. What are the two base angles?
B and C.
B and C. Base angles are the two that are the, and we're going to learn that those base angles, like Tori said, are congruent. Okay? But you don't know that just based on the definition. But this is one of the properties.
You know that because of like an isosceles prop, because the lanes are the same length as each other. That means the angles therefore are the same length too.
You are right, because remember when we listed the angles from least to greatest. So if the opposite sides are the same, then those angles are going to be the same. Okay? So this is theorem 51.1. So if a triangle is isosceles, then its base angles are congruent. If triangle is isosceles, then base angles are congruent. Here's how they prove it. They draw a midpoint. Here's how they prove it. They draw a midpoint of BC. Okay? And so they say that these are congruent. So if you were to create triangles there, then we would know that these guys are congruent, and these guys are congruent, and this is congruent to itself. So by SSS, these triangles are congruent, right? So if the triangles are congruent, every part of those triangles are congruent. CPCTC, remember that? So that means these angles have to be congruent. That's how they prove that those angles are congruent. So it's not an easy proof. They have to prove that, they have to find some congruent triangles and prove it that way. Okay, theorem 51.2. This is the converse of 51.1. So what's the converse say of 51.1? What's the converse of 51.1?
Base is congruent than isosceles.
All right, and so if base angles congruent, then triangle is isosceles.
That was a great lesson.
And actually, it says then the sides are congruent. So, which I don't think you need to do that. I mean, 51.2 combines the converse of 51.1 with the definition of isosceles. So technically 51.2 says if the base angles are congruent, then the opposite sides are congruent. Because it's an isosceles triangle. Okay. So here's corollary. Remember, corollary is like a addendum to a theorem. So this goes with 51.2. Corollary 51.2.1 says this: if a triangle is equiangular, then it is equilateral. And that makes sense because the opposite angles, if the two angles are congruent, their opposite sides are going to be congruent. So in an equiangular triangle, that makes sense. If triangle is equiangular, then it is equilateral. right? So Theorem 51(2) says if two angles are congruent, their opposite sides are congruent. Okay, so well, if this angle is congruent to that triangle, then these opposite sides are congruent too. So it's equilateral. Okay. So I'm going to erase this. We're going to talk about equilateral triangles.
I like equilateral triangles.
Yeah.
They're like pleasing, you know?
So here's Theorem 51(3). Says if a line bisects the vertex angle of an isosceles triangle. So let's get an isosceles triangle up here again. So if a line bisects the angle like that, if the line bisects the vertex angle, the vertex angle, sorry, the vertex angle is that top one, right?
Yeah. Vertical.
Then it is perpendicular to the base. Okay, it is the perpendicular bisector of the base. Okay, so if a line bisects the vertex angle of an isosceles triangle, then it is the perpendicular bisector of the base. Okay, so perpendicular bisector, that's two things. It's perpendicular to the base and it cuts it in half, it bisects it. Okay, so Theorem 51(2), 51(4) is the converse of 51(3). If a line is the perpendicular bisector of the base of an isosceles triangle, then it bisects the vertex angle. If a line is the perpendicular bisector of the base of an iso triangle, then it bisects the vertex angle. Okay? Okay, so this is how they prove it. Okay, so here's our situation. So basically, to prove Theorem 51(3), I'm going to look for two congruent triangles. I kind of see two congruent triangles. Do you see them?
Yeah.
And what do you know? Well, the only thing you know is that this angle, that these sides are congruent because it's an iso triangle. And we know that these angles are congruent because that is the bisector of that vertex angle.
And they're right triangles because of where you put it down.
Well, you don't know that yet. That's what you're trying to prove.
But don't you know that because you put the line down the middle, a
No,
straight line?
I cut this angle in half.
That's so annoying. That's
Okay,
what
but that's what we're trying to prove. Okay,
But it
so
is congruent.
it looks like it because that's what our eyes see, but this is what we have to prove it. So let's prove it. Well, we also know that the base angles are congruent, so we can do that. And we also know that this side is congruent to itself, right? So look, AAS proves that the triangles are congruent. So that means this angle, 1 and 2, have to be congruent to each other. If the triangles are congruent, all their parts are congruent. So these angles are congruent. And these are also supplementary angles. So if two congruent angles add up to 180, they have to be 90 degrees. So they're not, so then we just proved that it's perpendicular. But now these are the same because all the triangles are congruent. So if the triangles are congruent, all the parts are congruent. Okay? So to prove something is a perpendicular bisector, you have to prove two things. You have to prove that it's perpendicular, so it intersects at 90 degrees, and you have to prove that it bisects it, cuts it into two congruent parts. And we did. That's how they proved it. All right, that's lesson 51. Any questions? All right, let's move on to 52.
Mr. Flack,
Yep.
next time when you're using the green, could you possibly use a different color? It is difficult to see the green because it's so light and the glare from the sun just blocks it out. So I had a hard time with the pretest when I was rewatching it.
Yeah, this green is kind of lame. And I set the camera up a little different. So now it's a better angle and there's less glare. So hopefully it'll be better from now on, but I'll keep that in mind with the green. Okay, lesson 52. So we're going to talk about the properties of some quadrilaterals, rectangles, rhombuses, and squares. You would think that the plural for rhombus is rhombi or something, but it's not. It's rhombuses. Okay. So let's start with the rectangle. Let's just draw a generic rectangle here. And so what can you tell me about a rectangle? Well, the only thing that we know is its definition. It's a quadrilateral with all right angles. This is the only thing we're given. But that's just the definition. What does your gut tell you, or what else can you tell me about a rectangle?
Right and the left sides are congruent.
Yeah, so these are congruent. The opposite sides are congruent. Okay, what else? Yeah, Kate?
Well, if it's just me, when I see a rectangle, I just think of a longer, skinnier square.
Yeah, so you could say, I mean, technically a square is a type of rectangle because the definition of a rectangle is all right angles and the square has all right angles. But yeah, but what else can you tell me? The opposite sides are the same length. What else about the opposite sides? They're what? Parallel. Yeah, so opposite sides are parallel. Okay, good. So let's see if those are some properties. I think they are. So here's a property of a rectangle that not yet, but the first property they say talks about the diagonals. Well, what do you know about the diagonals of a rectangle? What do they look like?
They bisect the angles and make triangles.
They don't bisect the angles. This angle's bigger than that. What about the two blue lines? What can you tell me about the two blue lines? Don't overlook the obvious.
Oh, you forgot
They
the
cross.
They cross, they intersect, but
transversal.
no, well, you could get there, but you're overcomplicating it. What do you know about the two blue lines? What's your gut tell you?
They're the same.
They're the same length. That's right. Diagonals are congruent. Okay. So property one, property of rectangle. Prop of rectangle number one. Diagonals are congruent. Okay. They're not perpendicular. In a square they are. In a rhombus they are. But in a rectangle they're not perpendicular. Or a rectangle that's not a square, they're not perpendicular. Okay. All right. So the diagonals of a rectangle are congruent. Diagonals of a parallelogram bisect each other, but they're not congruent. So if you look at a parallelogram, do these diagonals look like the same length? No, they don't, because this one looks a lot longer. Because see how it goes from far to far, and this one's a little closer to each other, right? So the diagonals in a parallelogram are not congruent unless it's a rectangle, because every rectangle is a parallelogram. Okay. So here's a property of a rhombus. What's a rhombus look like again?
It could be like
Like
a
a
square, or it could be like a kite. But can it be
It's
a
not
square?
a kite. Can't be a kite. Remember, a kite looks like this.
Yeah, it's a congruent kite.
Oh, it's
Or
where
a
it's
diamond, rather.
I don't know how to explain it, but I can draw it.
There's a really easy way to explain a rhombus.
Line. Oh, two sets of parallel lines.
That's true, but so is this.
That isn't that a
These are
rhombus?
two sets of parallel lines, but that's not a rhombus.
The same length.
Yeah, all sides are the same. It's an equilateral quadrilateral. All the sides are the same length. Okay? So here's a property of a rhombus. Prop of rhombus. What do you know about these diagonals? What does your gut tell you about these diagonals? They're not the same length, that's for sure.
Perpendicular.
They're perpendicular. Okay? So diagonals are perpendicular. That's how you spell perpendicular. Okay? Okay, the other property is that the diagonals are perpendicular not perpendicular, just angle bisectors, or bisectors of the angles. Bisectors of the angles. So do you see that? I'm going to use green just because I just want to show you here. This angle is the same as this angle. You see that? Which is the same as this angle and this angle. And then this angle is the same as this angle. And this angle is the same as this angle, even though I drew it wrong. So the diagonals not only are perpendicular they are perpendicular bisectors of each other too, because these sides are the same and these sides are the same. Okay. So these diagonals are powerful. They create four congruent angles. And they create these four congruent angles. So they create 8 congruent angles. Not to each other, but 4 to each other and another 4 to each other. Okay, so let's do some puzzle work here. Let's say that this is a rhombus. Poorly drawn rhombus, but it's okay. We're going to get over that. This is a rhombus. And this angle is 3x plus 12 degrees. And then this angle is x plus 10 degrees. So this isn't a property, but you could probably figure it out. Do you think this angle is congruent to this little angle, this acute angle?
What was that? If that one's acute?
Well, first of all, we can figure out another property because these are perpendicular, right? Because those diagonals are perpendicular to each other. So what do these two angles have to add up to?
180.
Well, all three of them have to add up to 180. So if this is 90, then these two have to add up to another 90. Okay? So I can create an equation to solve for x. 3x plus 12 plus x plus 10 has to equal 90. So far, so good? Okay, combine like terms. What is that? 4x plus 22 equals 90. Subtract 22 from both sides. 4x equals 68. Divide by 4.
That's not you.
X equals, what is that, 12? Or not 12,
Not 12. It's
17.
Yeah. And then you still have to like put it in. So
Yeah,
it's,
then you have to figure out the
17 times
angle.
3, which is 17 plus 17.
So this is going to be, let's see, 17 plus 10 is 27 degrees. And this is going to be 51 plus 12, which is 63 degrees.
And then you kind of can just backtrack and add it together.
Yeah,
to make sure.
And it's just those two angles all the way around. So this is 63, this is 63, 63, 63, 27, 27, 27, 27. Okay? I didn't mark this wrong so far, but I actually told you wrong on one of the practice test questions. The point that is equidistant from each vertex is not the centroid. It's not that. I messed up.
It's not a whole number because it's not exact because
Well, it is.
It's a
The
set- it's
centroid
seven.
isn't exact.
no, yeah, that's not exact, but you marked it at like a 6 and not a 7. You marked it wrong on top and
Oh.
the bottom.
Well, it was wrong altogether because it wasn't. It's not the centroid. That's the equidistance from each vertex. It's the orthocenter, which is the intersection of just the perpendicular bisectors of each side. Okay, so I'm not counting that question. If you've already done it, I'm not counting it.
What
If you
question
do it
is
right, I'll give you extra credit.
that? What question is that?
I don't remember,
It's
but it's
14.
fine. It's when those places are the same distance from whatever, and then you have to calculate where it is.
Oh,
I did it wrong on the practice test, so I apologize for that. Okay, the last example is just another quadrilateral here. And this is what the example looks like. It's actually on the coordinate plane. And the vertices are at -1, 4. And then 4, 6. And then at 6, 1. And then 1, -1. So here's what the shape looks like. And what kind of shape does that look like?
Rectangle.
It's a rectangle. It's more specifically a square. Looks like a square, doesn't it? And it's a rhombus, right? So a square is both a rectangle and a rhombus because it has all right angles and it has all congruent sides. Okay, so here's what the question asks. Determine whether the diagonals are congruent and classify the parallelogram. Okay, well, how do you determine whether the diagonals are congruent? Well, we'd have to draw them and then do the distance formula, which is awesome. Okay. So the distance formula, you can find the distance formula by doing this: square root of x1 plus x2 squared, or not plus, but minus,
Like,
plus, no, sorry. Yeah, minus. And then y1 minus y2, parentheses squared. You can do it that way, or you could just count and use the Pythagorean theorem. So you could draw a right triangle across like that, but that gets confusing with that square already drawn like that. It's a little weird. Okay, so use the distance formula for both of those, and you get the square root of 58, which who cares? It's an ugly number, but you get the square root of 58 for both of those lines. So that means the diagonals are congruent. So that was the question A, determine whether diagonals are congruent and classify the parallelogram. So since the diagonals are congruent, it's not only a rectangle, because remember that was a property of a rectangle, the diagonals are congruent, but it's also perpendicular because these slopes are opposite. Negative opposites. This goes down 3 and over 7. This goes up 7 and over 3. So see how they're flipped over and they're negatives. So that means they're perpendicular. So they're not only the same, they're congruent, but they're also perpendicular, which means it's a rhombus and a rectangle. What's a shape that's both a rhombus and a rectangle?
Square.
A square. So that's your answer to B, is classify it. All right. That's all I got.
Black math, give me some math and I'll give you some flack.